We're going to talk about an important renewable energy system that can be used to generate power and electricity, tidal power. Why is this topic important? With an increasing population and push to a digitalized world, we are producing electricity and burning fossil fuels at a higher level than ever before. With this increase in demand comes increased emissions. That is, unless we can develop sustainable, renewable technologies to meet this demand and help reduce our emissions. A particular greenhouse gas, carbon dioxide, plays a large part in the process we know as global warming. At the rate we are currently producing CO2, our atmosphere is at an imbalance. Our natural carbon sinks like the ocean and land may not be able to absorb CO2 due to saturation and is leading to an increased concentration in our atmosphere. Looking at the electricity sector in Canada, greenhouse gas emissions from coal, natural gas, and other emission-heavy sources has decreased by 39% from 2000 to 2016. So what is causing this decrease in emission? The large part of this reduction in emissions is due to the increased generation from non-emitting sources like wind and solar power. While the growth in this area has increased and led to a decrease in emissions, these technologies still lack a predictability aspect. This leads to the question, what other renewable options are there? Tidal power exploits energy drawn from the movement of ocean tides to produce electricity. Tidal energy is considered renewable because the tides move on a predictable, daily schedule depending only on the orbits of the Earth, Moon, and Sun, and are essentially inexhaustible.
There are two main approaches to harnessing tidal power. The first is tidal stream technology, which convert kinetic energy of the tides to usable energy. There are three main categories of turbines: horizontal axis and vertical axis cross-flow turbines, which are similar to wind turbines, reciprocating devices with hydrofoils that move up and down the tidal streams, which either convert the motion into rotation to drive a rotating shaft or are connected to pistons that use a hydraulic system for power generation. Other designs in the research and development stage are rotating screw devices and tidal kites that carry turbines below their wings. Second approach is Tidal Barrage technology, which harvests the potential energy created by the difference in head between ebb and flood tide. There are three ways to generate power. First, by allowing the reservoir to fill at flood tide and releasing the water at ebb tide through a turbine. Second, by closing the reservoir at ebb tide, and then at flood tide allowing the water to flow into the reservoir through the turbine. And lastly, two-way generation on ebb and flood tides.
Countries with the highest potential for tidal energy have abundant access to coastlines. Features such as bays amplify flow properties such as tide height and current flow rate. Increasing these properties increases the amount of extractable energy. Countries that currently have significant tidal energy production or the potential for large production are Canada, the UK, South Korea, France, Russia, and China. The largest tidal plant is the Siwa Lake Tidal Power Station in South Korea with a capacity of 254 megawatts completed in 2011. The second largest station is Lawrence Tidal Power Station, which was completed in 1966 with a capacity of 240 megawatts. Annapolis Tidal Generating Station in Nova Scotia is the largest in North America with a capacity of 20 megawatts. There are numerous advantages associated with tidal energy. Water as a fluid is much denser than air, so the mass flow rate is larger and more energy can be extracted. Tidal patterns are much more predictable than that of wind or solar. There is much less uncertainty in knowing when tidal plants will be generating or not. Generally speaking, tidal power plants will take up less area than that of wind farms. For example, the generation capacity per square kilometer is higher for the Siwa Lake Tidal Station when compared to the large Roscoe wind farm in Texas. There are also numerous disadvantages associated with tidal energy. It can have a significant impact on marine ecosystems. Certain paints, lubricants, and materials for the machinery can be toxic. The electromagnetic waves produced from the generating stations can impact the sensory systems of marine life. This can disrupt migration patterns. Changing the currents also impacts life that depends on currents, such as planktons. Currently, tidal energy plants have large upfront costs. Costs are expected to go down as we learn more in manufacturing and as production and commercialization scale up. The Bay of Fundy in Nova Scotia has some of the best geography on Earth for tidal energy. It has the highest tidal height range in the world, high current speeds, and 2,500 megawatts can be extracted without significant environmental impact. Given the proper economic and geographic conditions, tidal energy can be a predictable source of carbon-free electricity that can help solve the global climate change problem.